Welcome to part 4 of Competency 14. In this video, we will work with conic sections. Okay, number 1. What is the circumference of a circle whose graph is given by the equation x minus 4 squared plus y plus 5 squared equals 49? This is a very simplistic question, slow rigor. What they're asking is, do you know what this really is, the 49? Well, that implies r squared, radius squared, and in our case, that is 7 squared. Okay, and also, we should all know the basic circumference formula of 2r pi, okay, or d pi, okay? So that's 2 times 7 times pi, which obviously is 14 pi. Leaving it in terms of pi, okay? Number 2. Now, they do something slightly different. They are wanting to know if you can make sense of area. What is the equation of a circle with the area of 144 pi and whose center is located at -8 and 2? Okay, well, we should know that 12 times 12 is 144. But you also know that area is r squared, radius squared. So you're going to know that you can put second and the radical. You could put any number they give you in front of the pi, because it's in terms of pi. Under the radical, push enter, and you see 12. Well, if we look over here, all of our options have that equivalency, either with a 12 squared or they have 144. So those are all correct, essentially. Okay, what this question is really testing you on is, do you understand the center and the equations? Well, this is when I'm going to use a calculator to point this out. Okay, so we are using apps, APSS, push enter. And we need number 4, the conics. Conics are all circles, ellipse, hyperbolas, parabolas. Okay, so let's push that, number 4. Okay, and you see it all lined out there. Those are the 4 things that it will help us with. It's very convenient. But we need a circle right now, so push enter. Okay, the format that our equations given in are number 1. And notice what's flashing the arrows. That's so I can change color. I'm going to leave it a bright pink. Okay. And our H is actually, this is H and this is K as given. Okay. I'm going to press enter because we want number 1. Now look at how they want us to put that into the calculator. It's negative H. That means negative times H. Well, H is already negative, so negative times negative is a positive. But we're going to let the calculator do all that hard work in a second. But it doesn't give you the equation the way they're asking it. You need to know it's negative times negative is a positive. Okay, but I'm going to go ahead and put that in the calculator. Okay, and then we need a positive 2. And our radius, by the way, you can put in the value as is for the radius. So let's do second under the radical 144, close our parentheses, and push enter. And look at what it does for us. Okay, so you don't have to go off to the side and do those calculations. Like I said, it's very convenient. Let the calculator do all the heavy lifting. All right, so that being said, negative times negative is positive. So we need to change this part to positive like option B. So option A is out. And that, look at option C. They have transposed our H and K, or rather our X and Y constants, our H and K for our center. So obviously that won't work. Okay, now we're down to two of them. Now, K is positive. So when we put it in as positive into the equation that we have over here on our calculator, that means our equation should say y minus 2, because 2 was positive in the first place. So this will not work. That leaves us with B. But while we have this in the calculator, let's go ahead and graph it. So all you have to do is just push graph. Oh, look, but my presentation is a little odd because I had some prior things in there. First off, we had a dot grid, and let's go into formatting and change this around a little. Let's put a black background, and here, let me just do it for you here. But let's take note that we already have a yellow axis, okay? Which, if you look at our picture, you could still look at this closely. You may have to, it's kind of light. With the dots, even and the light colors, you can still count and realize if you're looking at our coordinates, -8 and then a +2 for the y value, this means that our center is in coordinate 2. And that's what our graph has done for us. Okay. Let's back out of that. Let's go second mode and let's quit. What we want to do is go second, zoom, which format's above that. See, we want the blue. There we go. We want rectangle coordinates. It's very convenient to know that we can do polar. And we're going to leave the grid on, but instead of dots, let's go do a line grid. Push enter. And I had it on light gray, so let's leave light gray is a good one. And the yellow axis, we're leaving that. What we are doing is we're going to change this white black. And I've done this before in other videos, showed you how to do this. It's kind of cool to do this with students if they have those kind of calculators. Otherwise, for yourself, they just like it when you have a color that pops. Okay, so I pushed enter. So now I'm going to back out. I'm going to go back to my apps. And I'm going to say 4, enter, because I want my circle back. And I was working with 1. Now I'm going to graph. And there it is. And if we had to, we could count the grids and find out what we need. Okay, now let's go to number 3. What are the coordinates of the center of the circle whose equation is given as, and there's our equation. Okay, when we enter that in the calculator, we'll have to adjust that 30. But let's go second mode. It backs us out to where we need to be. Okay, kind of like goes backwards a little. Right, so let's push. We're still in circle, so we'd go ahead and just push enter. But we need number 2 because we're working with the actual equation. Now I need you to note where you have plus d equals 0. Well, you need the 30 on the other side. So you need to make this a minus and then put. That's all you're doing, okay, to enter it. So let's do that. Let's push enter. And our circle is red for this one. Okay. Now, I have everything entered in. But you may be looking over here saying, okay, I don't get what's A, what's B. Okay. For this format, this the this is 1 in front of A. I mean 1 is a coefficient in front of the X. It is also the same coefficient in front of the Y. So those are the values of A, and 6 is B here. Let me change colors on that so you see. Okay. Now we're looking for B, and this is C, and this is D, but that's -30. Okay, now look at what I have. I have the coefficient of 1 for your X and your Y. Go down. 6 for your X. And then, oh, by the way, that was 1 for X and Y squared. Be specific, right? Okay, then C is in front of our Y. And then we have the constant of -30. Okay, so let's push graph. And this is how it would look. Okay, and I have yellow for the axis again. I mean, you can change that if you don't like it. You know, it might be easier to count if you made that a brighter color or blue, light blue or something. But anyway, we can see. But you want to know what the center is. Well, do we really need to do all that counting? Not really. Let's use our handy dandy trace. Okay, see where your little X is flashing? Bing, bing, bing. Okay, you need to know that it will trace. It only traces going because it's a circle, not a line, not a curve that we're used to, right? So it will only go counterclockwise. Well, how do we get it to do that? Well, push your arrow over, your right arrow over, and look at how it changes. But I'm going to go back to I'm going to push the other arrow. See me trying? That's as far as it's going to get. Notice if you look down to the Y value, it's negative 10. Well, guess what our Y value is, sweetie? Negative 10. And I see that right here with C. Okay. All right, which that may be great for us. Okay. But let's use our other arrow to go the other direction. And remember, I told you it'll only go counterclockwise. So let's keep going till we get to the top. See it flashing? There, it's smack dab on the top. And look at what our X value is. Because the truth is, we would be making a great big X in the center of our circle. And X would mark the spot right in the center. So we need that -3. And look, we have that right there. There's our negative. Oh no, what is happening here? Something. Oh no. Let me put that back the way it's supposed to be. Okay. So basically, C is going to be our option. But let me keep playing with this. I'm going to keep arrowing. And we get to the other side. And at the most left point, yes, our Y value is going to be. That's the center, the line that's going horizontally through our circle is supposed to be -10. But let's keep going. And then it should go back just as we need it. Right at the very base should be -3. That is your vertical slicing right through the center of the circle. So that would be a diameter line, okay? One that you can read, right? Okay. All right, so let's go to the next one. Number 4. What is the equation of an ellipse? Okay, we're switching to ellipse with its center located at 6, 0. Okay, now this is super important. Let's do a little highlighting here. This is horizontal major axis. Okay, so let's go second mode. I can show all of this on the calculator without, a bunch of graphics and things and explain this. Now, if you're still shaky with the information, you just don't remember this, it's been too long, go back. There's some great videos online. Get you a book, old pre-cal, anything you've got hanging around. Just brush up on it. Come back to the video. Okay, so we want ellipse. That's number 2. Okay. Now, which ellipse do we want? Okay, that's a conundrum. Okay. They have said horizontal major axis. Okay. That means it's going to go from here to here. So that will be the shape. That's going to be the shape of your uh, ellipse. Oh, I'm sorry. Okay. So first off, let me go to read the rest of it for you. It says major axis with length of 14 and a minor axis with a length of 8. What do I know? Okay, so I know I've got my horizontal line right here. Here's my center. What do I really know? I know that 2 times 2 times 8 is 14, and 2 times 4 is 8. So this 7 here will be, it's the largest value. It will be on my major axis, and it will be equal to the A that we need in our calculator. 4 will be my B value that I need. It will be on the minor axis. What do I mean? I mean that distance is 4, this distance is 4, and then along the major, this distance, oh, sorry, wrong. Okay, this distance is 7, and this distance is 7. Okay, let's go to my calculator. Since A is the larger value and it is on the major axis, I know that is the x-axis. Okay, so I will associate it with the x minus h. So I will push enter. Okay, and my A value should be 7. And I enter. My B value should be 4, and I enter. Now let's look. What is my H? What is my K? Well, I go up to the center location they gave me. So my H is 6, I enter, and my K is 0. Okay, so let's graph this. And that makes sense. That is what it should look like. And I'm going to back out and change that axis color. That's kind of nice the way it has the grid. Let's go second mode and quit. I'll come back to it. Let's see. Let's see. Let's go down to where it says yellow axis, and we need to come up with, let's not use white, a blue, light blue. Let's just do that because I know that's going to pop. Okay. So let's go. I'm going to back out just in case. Okay. Now we go 4, 2 is ellipse. We wanted the first one and graph. Okay. I don't even know if that's better. Okay. At least I see it a little better. Okay. And I could do some counting and figure things out. But what they want to know is what should the equation look like? Well, I know that I should have 7 times 7 is 49. Remember, because A, here, let me back out and go to this part. Right. Oh, nope, that's wrong. I am so sorry. I need to go to 2. Okay. So I know that my A needs to be squared because A is on the major. They told me horizontal. Okay. So I know that it's associated with the X and it has to be 49 squared. And then my 8, okay, well, 4 times 4 is 16. Well, I can get rid of this guy and this guy. So now I'm left with A and C. How do I know the difference? We'll go back to the rule that we used back prior in number 2 and look at our calculator. It says negative H. Well, that would be minus 6. Well, the only one that's correct then that has minus 6 is A. Okay. Because C implies that we would have been given rather a negative 6. So that won't work. So A is the appropriate option. Number 5, given the equation of an ellipse is, okay, they give us the equation. Which image represents that? Well, now that we know how to enter things in the calculator, we've got this. So we push apps, and that's an ellipse equation. And it tells us it's an ellipse. So what do we need? We need 4 for conics, 2 for ellipse. And which ellipse do we need? We need the one that has A, wherever A is greater. Well, we can see that A here will be 10 and B here will equal 4. So that means we need number 1. We push enter. Okay, so we need to put A is 10, enter. Oh, no, I have B wrong. That should be 2. I'm sure you guys saw that when you did it wrong, crazy. Okay, so that would be 4. And now our H it is just 3 because we have a negative in front. So that would have been minus positive 3. So just push 3, enter. Now for K, that isn't the case. K is minus a negative 2 because a negative times a negative positive. So let's put this in minus 2. Remember, you have to push enter. Okay, which I did. Now let's push graph. And there it is. Well, the only one that even looks remotely correct is option A. As you can see, B and D, they have the major axes wrong. It would have been if you flipped it, if you flip your A and your B and you enter it incorrectly. You have to know what you're looking at. Like I explained to you, the major axis is always going to be called A in the calculator, and it will always be the greater value. Okay. Right. And there's a reason why all that is. Like I said, you can watch other videos about that. If it comes up in a question, I will explain it. But that's not the purpose of our videos, to go into depth. All right. So let's look at number 6. Okay. Given the equation of the ellipse, here we are again. Oh, okay. They give us the ellipse and it says, what are the coordinates of the endpoints of the major axes? Well, we have our calculator app. We can just trace. Actually, you can also just look at our calculator and count. We don't have numbers. It's up to you. And that's why I put the little grid on so you could see that you can have a grid. Now, it also depends on what kind of calculator you're using. Some of the yellow school ones, they don't do all these great, wonderful color options. Depends on what the school district paid for. Okay, so let's do trace. Oh, and he's right on it. So, okay, looks like we have 13. That's for the very right. So we need 13 and negative 2. So let's find those. Anybody who's not 13, negative 2, we don't want him. Oh, there's a negative. We don't want this one either. So these two are out. Okay. All right. So remember, you can only use certain arrows. So we need to use the right one. See, now it'll go straight up to the top, which is great. That'll also help us with if we need it, we can see that the center is at x equals 3, which is kind of convenient. But they didn't ask us for that. They wanted us to get the end values. Oh, I'm going the wrong way. Like I said, we got to keep going the correct way. All right, so there we go. One more. Okay, there we are. Now we need -7, -2. And that's option C. Very nice. I love that I don't have to sit and calculate that during a test. Number 7. Given that the equation of an ellipse is, there's our equation, what is the distance between the center and one of the foci? Okay, here's the thing. You need to know the properties of the ellipse and the equation and remember how to do this. So what are we looking at? First off, you need distance, so you're keeping everything positive. And what are we doing? We are taking A and B, okay, which I explained prior. Distance is the square root of A squared minus B squared. Ladies and gentlemen, A is always larger. And because A is always larger and we use this particular equation, we do not have the issue of the complex numbers. So so we have two things eliminated. We don't have to worry about a minus under the radical, and we do not have to worry about a minus in front. So we're going all positive, which is super convenient. Okay, so for us, that means that would imply that we have under the square root 81 minus the 25. Remember, this is 5 squared and 9 squared. 9 times 9 is 81. 5 times 5 is 25. Okay, we should know that. Okay, and this is going to equal that 56. Pop that in the calculator. A second radical 56. What do we get? Positive 7.48. Notice you had, of course, these aren't right. This was close, but no dice. So we have 8. Okay. All right. So let's look at number 8. It says, using the information from question 5, that's above, what are the coordinates of each focus? Okay. All right. That's kind of a deal where I'm going to have to just lay it out for you. Okay. All right. So let's look over here. Which one is greater? The 25, the A or the A and the B. Well, B was equal to 9. And it is associated here. It's associated with the Y value. Okay? If it's associated with the Y value, this means our ellipse is like this. And our center right here, okay? Let's look at that. Let's just pop it all in the calculator. Just get this explained and done with, okay? They're asking, well, we know what the center is, actually. And we'll pop it in the calculator, okay? But our center, if we look up here, we have plus 1. So that means minus 1 because a negative times a negative is positive, okay? Go over to the 7, the y plus 7, same thing. That means negative 7, okay? So that means that this point, this is the minor, okay? But that was negative 7 going up and down like for your y. And then this is x equals negative 1. And you could say that that's y equals, okay? So this tells me that, change colors, that from here to here, from this negative 7, that will be, we're going to go up. So that is plus 7.48. But if you go down, because remember, we're on the major axis, that's minus 7.8. Okay? And let's look at what this will look like for grins, just to do it. So we need 4, choose an ellipse. It said ellipse, yes. Okay, let's put this in the calculator. We had A is associated with the y-axis, so we want to go down to number 2, push enter. Okay, our A value was 9. Our B value is 5. Our H is, remember I said it's going to be negative 1. And then for our K, we have a negative 7. Okay, push enter. Remember, if you don't push enter, everything will go haywire. It won't work. Okay, push graph. Okay, look, nice. Okay, you could, do some counting, but that doesn't help you with a full guide. Okay, so we're going to go positive, negative from negative 7. Okay, first off, that is, hang on, let me put this here. That's bothering me. Okay, it says, what would the graph be? Well, we know that x is going to, will be rather negative 1 for both. So in the x position, this does not change. It is the negative 7 that is plus or minus. So you need to come over here and make note of both of these must be negative 1. And if they are not, then those options are invalid. Now, look at our choices left of B and D. It cannot be option B. It simply will not work. Our center is negative 7, negative 1. Your center cannot also be a foci. Okay, that alone gives you a way to get rid of it. However, we still need to pop in the calculator and calculate. I need to show you that. So let's go second mode and go quit. Now, we need positive, negative from the minus 7. What do I mean? I mean, you literally put minus 7. Let's do the plus first because that would be the first thing in. Plus 7.48. Push enter. That's your first option, and it is. Okay, that is. Now let's do the second one because it's below it. What do? I go up, I capture, go over, and I literally just pop in the subtraction. Push enter, and that is actually the value. So D is the appropriate option. Now, let's look at number 9. What are they asking in number 9? It says, given the equation of the ellipse, you see something familiar? And it says, what are the coordinates of the foci? Ugh. So what have they done? They have played a switcheroo on you, okay? They are now changing your major axis and associating it with your x. This means it will go this direction, and you will measure it from the -1. Okay, it's flipping. Remember, x equals -1. So you measure going horizontally instead. So this means that you will have plus, okay, remember you go in the plus direction here, 7.48. And the other direction, you're saying minus 7.48. And it will be the y value that is not allowed to change. And that will be y equals minus 7. So you come over here to your options, and minus 7 should be unchanging for both y values. Okay, so this means this does not, oh, sorry, let me just get rid of this. I'm not helping out with that. This does not work. And let me go back to the highlighter and see if I can find. Looks like I have a mistake. Okay, sorry about that typo. It's been fixed. Okay, so if we look at this, we can just put it into our calculator. So we have -1 minus 7.48, and that gives us -84. Well, you could have done that with your eyes, but either way, we can see an option. Let's see. Minus, okay, A, maybe. Okay. And C, maybe. Okay, but obviously D will not work. Okay, and B does not work. Well, I can tell you right now that A doesn't work. Why does not A not work? Because we must have, for the Y value for both, it must say -7. And the only one that does that is C. Okay, and if we have 7.48 minus 1, then the only option that works is D. Okay, this is the last question for this video. And once again, if you haven't subscribed and you're enjoying these videos, please do so. We need the subscriptions so we can stay free on YouTube. Otherwise, they will have to be pulled, sadly, but we want to offer these things for free. And also, don't forget to like us and share us. Share with somebody. See if someone else will like it, like our videos. Happy testing.